So this particular example, we're working with scatterplots, and we're going to first of all graph the order pairs from the scatterplots or from the data, and then we're going to put a line of fit in there, and then we're going to make a prediction. So it says the table shows the daily high temperature and the number of hot chocolates sold at a coffee shop for 8 randomly selected days. And as you can see, the information in the table is given. Part A says make a scatter plot of the data and draw a line of fit. Now, in order to make a scatter plot of the data, the first thing we want to do is we want to label each axis. So down here, according to the table, our x-axis is the temperature because right here it says x. And then on the y-axis, we have hot chocolates. All right. So now we need to figure out the scale in order to draw this particular scatter plot or to plot the points. So notice that for my x values, my smallest value is 30, my largest value is 82. So according to the space that I have from this small grid line, I'm going to decide to go with 10 as my scale. So that means each grid line is going to be 10 units. And as you can see, each grid line, I'm making it 10 more. Okay? So 90, 100, 110, and 120. Now, up my y-axis, I'm also going to use 10 as my scale because my smallest value is 17, my highest value, actually, I'm going to change that. I'm going to use 5 as my scale because my smallest value is 17, my largest value is 45. So I'm going to use a scale of 5 on the y-axis. Now, I can have a different scale between the two different axes. However, on each axis, the scale must be equivalent. What I mean by that is it is okay for me to use a scale of 5 on the y-axis compared to a scale of 10 on the x-axis. But if I start on the x-axis with a scale of 10, I have to finish it out with 10. Same thing over here. If I start with 5, I have to go all the way up with 5. Okay, so now I'm going to plot the ordered pairs. So notice I have X and I have Y. So each ordered pair, so for example, when I have 30, 45 in the first column, that's going to be the ordered pair 30, 45. Okay, same thing here, 36, 43, 44, 36. Okay, and I'm just going to do those two examples. That's from the first two columns. So I have 30 and 45. So let's change colors. Let's do a different color. Let's go with this color right here. All right. And 30, 45. So I'm going to go to the x-axis, go to 30, go up to 45 on the y-axis. Right there. I have 36, 43. So 36 is probably about a little more than halfway between 40 and 30 and 40. And then we're going to go up to 43. So that's about right there. Now it's not going to be exact, but it's okay. 44, 36. So 40, let's go almost halfway. And 36 is going to be about right there. And then I have 51, 35. So 51 and 35. All right. 60, 30. 60. And then I'm going to go to 30. And then 68, 27. So 60 go to 68, 27. 75, 23. 75 halfway between 70 and 80. 23 about right smack in the middle. 82, 17. So 82 and 17. All right. Now these order pairs aren't going to be exact. They're not written to scale, but you get the point. So now it says draw a line of fit. Now this line of fit, we want to try to draw a line that gets all of these data points as close as possible. Okay, so we want to get them as close as possible to each other. And I'm going to go with that one. Let's change the color of this. Let's make this green. So my line of fit is going to be like this. Now, it's just an estimate, so everyone is not going to get the same line of fit. You want to try to get some of these data points from the table on that line of fit. However, sometimes you may or may not have any on there. Okay, so now I have B, so B is my line of fit. A, I've done my scatter plot and drawn the, I'm sorry, A, we've done the scatter plot and drawn the line of fit. Now for B, it says write the equation of the line of fit. Now in order to do that, in order to write the equation, I must have, I'm going to write it in slope-intercept form, which is y equals mx plus b. Okay, so this is slope-intercept form here. And what we need in order to do this is we need the slope m, and we also need the y-intercept b. Now, in order to find the slope, we have to have two ordered pairs. So let's choose two ordered pairs. I'm going to take this one right here because it's already on the line and it's from the data set. And then I'm going to take this one right here because it's already on the line and it's from the data set. So, and when I do that, I'm going to use my slope formula, which is y2 minus y1 over x2 minus x1. Now remember, m is the variable that we use to represent slope. All right, so also what I'm going to do is I'm going to write the ordered pairs up here somewhere. So we're going to say this ordered pair is 60-30, so 60-30. And then we have the ordered pair, this is 75-23, so 75, comma 23. All right, now with that, I also want to label these x1, y1, so I'm going to say x1, y1, x2, y2. All right, so y2 is 23, so I have 23 minus 30 over 75 minus 60. Okay, so 23 minus 30 is negative 7 over, let's see, 15. And that is my slope, okay? So I have a slope m, which is negative 7 over 15. Now I need to find b, my y-intercept. And to find the y-intercept, it is simply where the graph intersects or touches the line, this line of fit. It's where this line of fit touches the y-axis. And if you look right here, that's about 57, okay? This line touches the y-axis at 57. So B equals 57. All right, so that's the y-intercept, okay? So remember, y-intercept, and then this is slope. All right, now, so I can rewrite, and this is part B, I can rewrite this equation, y equals mx plus b, but I'm going to change my m to negative 7 over 15, and then x plus my b, I'm going to change that to 57. Okay, so here's our equation for part B when it says write an equation of the line of fit. Y equals negative 7 over 15x plus 57. Okay, now with that, we can go on to part C, and part C tells us that we need to interpret the slope and the y-intercept of the line of fit. Okay, so if we interpret that, we're simply going to state in our own words what that slope represents or what it means. What does it mean? Okay, so since the slope is a comparison of the y change to the x change, since y represents the hot chocolates and it's negative 7, that means the number of cups of hot chocolate sold decreases by 7 as the temperature increases by 15. So cups sold decreases by 7 as temp, I'm going to say temp instead of temperature, increases by 15 degrees. Okay? So, and as you can see here on the x-axis, as the temperature increases, the number of cups sold decreases. All right? So then last but not least, we have part D. And part D simply asks us to predict the number of hot chocolates sold when the high temperature is 20 degrees Fahrenheit. So we're going to take this equation and we're going to just simply change x, because the temperature is our x value. We're going to change x to 20 because they tell us the temperature is 20. All right, and then plus 57. So when I do that calculation, that's going to give me what that value is. And so if I have -7 divided by 15, it's actually approximately negative 0.45 or negative 0.467. And if I multiply that by 20, it's going to give me a decimal. And so it's technically negative 9.34 and then plus 57, which equals 47.66. So 47.66. But I would just round that up to, you can round that up to 48 degrees, or you can actually take this part right here, instead of putting negative 9.34, you could just say -9. So either way works because it's just a prediction. It's just the estimate. And if you actually go back to the graph, when I look at where the temperature is 20 degrees down here, at 20 degrees, I'm going to go up and it says it's going to be about 48. And notice this is approximately 48. So this is our predicted value right there. And we did a pretty good job of predicting that value. So at 20 degrees, so it falls on the line. Now it may be a little bit off from the line, but it's only because it is a prediction. So this is how you work through all 4 of those parts of this particular problem.